roughly about the concept. So moles, the molar mass, is similar to this particular quantity, 26 to 30 shrink per pound of strength, and that is the grams per mole of chemical there. Okay, so if I ask you to give me, now the question here is that with that same molecule there, glucose, okay, we ask you what is the if you have one molecule of glucose there, what is the mass for the relative mass for that molecule? We calculated it's 55.847 atomic mass unit. Now, take that question a step further. What is the mass of 1 mole of iron there? Oh, not the glucose there, it's the iron there. Thinking about too many things at the same time there while I'm talking about this particular topic. At the beginning of this particular class today, we say, well, 55.847. Something is missing. The unit was missing there. So 1 atom of iron is 55.847 atomic mass unit. And the relative mass is 55.847. Now, if you have 1 mole of iron atom, it would weigh 55.847 grams. So we always start at the atom atomic level there, and then we go to the molecules and the compounds there, and we add things together. So in this particular case, the example that we give you at the beginning of the lecture there, 55.847, it represents the relative mass for 1 iron atom. It also represents the mass of 1 mole of iron atom. There are 6.02 times 10 to the 23, that many number of iron atoms in there. So 1 mole, that's 6.02 times 10 to the 23. That many number of iron atoms would weigh 55.847 grams. So if I ask you to give me a mole of iron atom there, you go to the laboratory there, you measure out roughly about 55.847 grams of the iron there, and come back to me here. That's 1 mole. So for elements, we need you to be able to identify the relative mass for each atom. We also need you to be able to identify the molar mass or atomic mass for each mole of the atom there. So in the periodic table, if you look at the copper, number 29, okay, and the number associated with that atom there is at 63.546. So each copper atom weighs 63.546 atomic mass unit. Each mole of copper atom would weigh 63.546 grams. Okay. So this is where we can quantify the amount of chemicals. Counting by weighing, that's the whole idea of the mole concept. Very, very, very important concept there. Have to pay attention to that. So for 1 mole of different elements there, they would weigh different in different grams there. For sulfur, 32 grams. You get magnesium, 24, tin, 118, silicon, 28.08, and copper, 63.5. Okay, so that's what the number means in the periodic table. And the number represents the relative mass for each single atom for that particular element. It also represents the mass in grams for each mole of those elements there. Okay, so whenever we ask you to get certain moles, a certain amount of moles of chemical out, and you don't go there and count the number of atoms there, rather you go and by measuring the mass. So if I need 3 moles of magnesium, you go and measure out 24 times 3, 72 grams. Okay, and then come back and say, well, that's 3 moles of magnesium. Okay, so that's what the mole concept gives us. In the periodic table, the number represents the mass equivalent in grams for each mole of the elements in there. So that's very important. That's something that we need you to remember. Okay. Now, for compounds then, how do we determine the mass of the compound, the relative mass of the compound? Well, we did the relative mass of the compound, glucose, 180.157. I was 3 slides ahead of myself when I was giving you the example there. So for the compounds here, when we did this example there, for glucose, we have carbon 6, hydrogen 12, oxygen 6. We know each carbon weighs 12.011. Each hydrogen weighs 1.0079, oxygen 15.9994. You multiply the number of each atom by the subscript, you add everything together, you get 180.157. Then we ask you the same question. How many grams a mole of molecule, a mole of glucose molecule would weigh? Weighs the same number. The units is different. This is the unit for a single molecule, atomic mass unit. This is the unit for a mole of glucose molecule. So each mole weighs 180.157 grams. Now, what this is the molar mass of compound. It's our new conversion factor. We can ask you, if we have, say, 3 moles of glucose, we want you to convert it into grams. Well, this is the calculation you're going to do. 3 moles, each mole, 180.157 grams. So mole and mole cancels out. You get grams. Now, if we have 250 grams of glucose, we want you to convert it into moles, then each mole, 180.157 grams. And gram cancels out. So what we have discovered here is that this particular number that we can come up with, based on the atomic mass, based on the formula of a compound, is our new conversion factor. Once you have the conversion factor identified, we can ask you to convert quantities from moles to gram or from gram to mole, depending on which way the question is asking, what conversion the question is asking you to. So all you need to do here is that once you identify that conversion factor, and you plug in the conversion factor, you'll always multiply the conversion factor, cancel out the unit, setting up the equation so in a way that you can cancel out the unit you don't want, then leave you with the unit you do want. So this is the conversion that we're trying to get into. Now this is how we quantify the amount of chemicals that we're working with. Very important concept here. Okay. Some of the questions in quiz number 1 are related to this particular type of calculation. So you give you 180 grams of glucose there and asking you to convert it into moles. Well, the conversion factor is 1 mole equivalent to 180 grams. Okay. So this is something that we want you to be able to do calculation with, and introducing a new conversion factor. That's pretty much my job for the next 4 weeks there. Giving you new conversion factors, introducing new conversion factors, so that we'll at least show you how to identify the new conversion factors so you can do dimensional analysis. So 1 mole of different compound, they will weigh different mass, just like 1 mole of different atom, they will have different atomic mass unit there, or in grams there for each atom there. So aspirin, carbon 9, hydrogen 8, oxygen 4. Each mole of aspirin will weigh 180 grams. Okay. Each mole of copper 2 chloride, dihydrate, well, this 2, we just mentioned this at the beginning of this class here. This 2 here indicates the charge on copper. What's the charge on copper then?
2 plus.
Positive 2. How about iron 3 oxide?
3 plus.
3 plus. So this formula here, when we have the name there, and when you see this number here, that number indicates the charges on the metal ion, on the metal elements there. So iron oxide will weigh 160 grams, 159.7 grams. 1 mole of water will weigh 18.02 grams. Okay. So how do we get all these numbers? We simply add the atomic mass together. H2O. Okay. We have 2 hydrogen, 1 oxygen. Oxygen is